Okay, looking at problem 39, these radical functions admittedly are not a whole lot of fun, but something I thought we should get a little bit of practice at here moving forward. So, same directions here. We're finding our general derivative first. So f prime of x will equal a limit as h approaches 0 of, and here we go, f of x plus h is going to have us just replace that x right there with an x plus h. So it would be the square root of x plus h and then a plus 4 at the end of that. So that's it for the f of x plus h, minus f of x, which is the original function, just the square root of x plus 4, all over an h. Now, algebraic manipulation in terms of, expanding a binomial, distributing, combining like terms doesn't really help us with a problem like this. What we need to do instead is to find kind of another way around it, and this might harken back to something we did with limits back in chapter 2, you guys. We're going to multiply both the numerator and the denominator of this fraction by the conjugate of its numerator. That would be the square root of x plus h plus 4. That pen's a little thicker than it needs to be. Okay, gotcha. And then it's going to be plus the square root of x plus 4. Gotcha. But you've got to do the exact same thing in the denominator. Square root of x plus h plus 4 plus the square root of x plus 4. So, what's that going to accomplish for us? Well, hopefully that's going to clean up our numerator here quite a bit. So what we are doing, even though it's messy here, guys, is we are foiling two conjugate binomials up here in the numerator. So the first product, this term times this term, well, those square roots are just going to cancel out and leave us with an x plus h plus 4. Every time you FOIL two conjugates, your outer and inner products are going to cancel each other out as well. So this product and this one right here are going to end up being exact opposites of one another, and they're gone, so don't even bother writing them out. And then the last product, this times this, is going to be minus, and that would be the quantity now, x plus 4. So I'm putting that in parentheses here, but if you were smart enough to go ahead and distribute the negative, cool, good for you. I guess I overshot it. I don't think that fraction bar needed to be that big. Now down in the denominator, do not waste a whole bunch of time trying to do anything fancy. Leave it in factored form, which is going to be h, and then that's going to be multiplied by the square root of x plus h plus 4 plus the original square root of x plus 4. Now, I want to remind everybody, the problem here all along, the reason we couldn't evaluate the limit was because of this h down here in the denominator, and you can't let that equal 0. That h is still in the denominator, but the hope always is that that h is going to cancel out. Well, if you take a look at what's going on in the numerator, I'm going to take some liberties here, guys, but I hope you can follow along. That's going to happen. This x right here is going to cancel out with this x once we remember to distribute that negative. So that's an x minus x, and those are gone. Likewise, here's a positive 4 that cancels with a negative 4 once you distribute the negative in there. And what does that leave in the numerator? Just an h. And because that's the only term left in the numerator, it can cancel out with this h down here on the bottom. So what that does for us, guys, is it now frees us up to go ahead and let h equal 0. Everything is gone in my numerator when I canceled out that last h, so we just put a 1 in its place there. And then down in the denominator, we've got the square root of, that'd be x plus 0 plus 4, so that is just x plus 4, plus another square root of x plus 4. So let's put all that together now, guys, and I think we're going to have our derivative now. F prime of x equals, that would be a 1 over, and anything plus itself is 2 times whatever that thing is. 1 over 2 times the square root of x plus 4. And that is our derivative now. I should say our general derivative, f prime of x. And if that's all the question was asking us to find, we would be done. But they're asking us to go a little bit further here. We're going to find f prime of a when a is equal to 1 and the equation of the tangent line. So let me switch colors right here. Let's go ahead and find f prime of 1 here. That'll give us a 1 over 2 times the square root of, 1 plus 4 is going to be 5. and there's not much we can do with that. Now, if I were your Algebra 2 or your pre-calc teacher, I would make you guys multiply both the top and the bottom of that fraction by the square root of 5 to rationalize it. But at this level, you guys, in keeping with AP guidelines, we don't have to rationalize denominators. So you can stop right there, and what we just found is the slope of your tangent. The other thing we're going to need is the point of tangency, which comes from f itself of 1. And to do that, I got to go all the way back to the original function there up in black. Oh yeah, it was just the square root of x plus 4. So let's go back to where we were right here. That would be the square root of x plus 4 now becomes 1 plus 4, and that is going to be the square root of 5. So that means that the ordered pair 1 square root of 5 is, let's put it right here, our point of tangency. So now that we know the slope of the tangent and the point of tangency, we are ready to go to point-slope form. Y minus your y coordinate at your point of tangency, root 5, is equal to the slope of your tangent, which is this ugly number of 1 over 2 root 5, and then in parentheses, x minus your x coordinate, or your a value, which in this case is 1. So there's the answer in point-slope form, and if you wanted it in slope-intercept, 2 steps here. We'd have to distribute that ugly slope there, so, sorry, y minus the square root of 5 equals, that would be 1 over 2 root 5x minus 1 over 2 root 5, and now we would add a root 5 on both sides, and boy, that's going to be really unpleasant to deal with. But I'm pretty sure if you look at their answer in the back, they didn't spend a whole lot of time simplifying that. So I'm just going to leave this as y equals 1 over 2 root 5x, and then, boy, I guess I would just probably write that as a plus 5 and a minus 1 over 2 root 5, and probably call that good enough. I don't think we need to spend a whole bunch of time cleaning up that constant into something else. Okay, so there is problem number, I forgot what that was, 39, I think? Yeah, there's number 39, everybody.